Okay, today we're doing unit 1, day 4. As you can see from the objective, we need to cover all the characteristics with this unit. Now, we've done a lot of these already. We've done equation, we've done the graph, parent function, transformations, domain and range, and even the asymptotes. So you can see the new stuff is in the middle here. Okay, all of this is new. Okay, so that's what we need to look at for each of these functions. We've done 9 functions, remember. So let's look at the linear function. So remember, you still need to know the other stuff, domain, range, and so forth. So this one goes up to, and we could fill in the points, and there's your linear function. So you still need to know your transformations, domain, range, and all that good stuff. So here's the new stuff. Now, some of this is easier than others. So the x-intercept, which is your 0 of the function, where does it touch the x-axis? -2, 0. Okay? The y-intercept, where does it touch the y-axis? 0, 2. So those are actual coordinates. Now, the increasing, decreasing intervals. So as you're drawing this graph, from left to right, think of it as going uphill or downhill. So as you draw the graph, see how we're going uphill from left to right. So that means we are increasing from left to right. Now, think of your domain. Remember, the domain here is all reals. So we're increasing from -infinity, less than x, to +infinity. So that's one way to represent this. The other way is your interval notation, kind of start and stop. So there's 2 different ways to represent increasing, in this case, the increasing interval. Now, in behavior is a little tricky. Okay, well, let me talk about turning point real quick. Turning point, there is none on this one because we're going uphill the whole way. All right, we'll get a turning point here soon. The end behavior. So think of, let me get rid of the blue line here. Think of your end behavior as your arrows. Where is our graph going? So think of your x-axis. If we keep going to the left, we get to -infinity. Keep going to the right, +infinity. If we go down, we go to -infinity, eventually up top, +infinity. So the left-hand end behavior, so as we're going to the left, so we're going this direction, where are we going? Well, the x is going left, so it's going to -infinity. The y is going down, so it's going to -infinity. So we would say, as x approaches -infinity, y is approaching -infinity. And that's referred to as your left-hand end behavior. As we're going to the right, x is going to the right, y is going up. So your right-hand end behavior, x is approaching +infinity, y is approaching +infinity. So that's how you handle your end behavior. So that's a typical linear function. All right, the next up is our quadratic. Okay, so again, remember all your old characteristics. So this one goes left 2, down 4. So left 2, down 4, that would put us right there. We build our quadratic. So hopefully you guys are good at this stuff right here. Okay? So there's your quadratic function for this particular equation. Okay, now again, fill in what we know. The x-intercept, which again is your zeros of the function, we actually have 2 here. We have -4, 0, and 0, 0. Okay, so we have 2 x-intercepts. The y-intercept, 0, 0. All right, now, again, let's kind of walk on this graph from left to right. See how we're going from left to right. We're going downhill. And then we hit this point, and then we turn back and go uphill. So this kind of cuts off our intervals right here. So left of that, we are decreasing from negative infinity to -2. Okay, we're decreasing from negative infinity to -2. So this is the other way to represent that. We hit this point here, which is referred to as our turning point. So -2, -4 is our turning point. And then we go uphill to the right of that. Okay, so we're increasing from -2 to positive infinity. Now that turning point, that point -2, -4, that's referred to as the extrema. Okay, extrema. Let me write that word there. Extrema. Okay. Now we also want to refer to that as a max or a min value. Now can you see kind of how it's at the bottom of our graph? So that is a min value. All right, that's your extrema. Okay, end behavior. So again, look at your end behavior. Look at these guys. That's your end behavior. So as we're going to the left, what's x going towards? What's y going towards? Well, as we go to the left, x approaches negative infinity, y approaches positive infinity. Because as we're going to the left, x is going to the left, y is going up. Okay? Your right-hand end behavior, as you're going to the right, your x is going to the right, your y is going up. So, your right-hand end behavior, x approaches positive infinity, y approaches positive infinity. Okay? And there you have it. So that's a typical quadratic function. Absolute value function. So this one goes right 3 up 2. Okay? Forms that V. It does flip. Remember, it flips the x-axis here. That's why it's opening down. Okay? So that's why the graph looks like such. So we still need to know all of that information. All right. The x-intercepts got 1, 0 and 5, 0. The y-intercept, 0, -1. So again, those should be fairly routine, but of course you need to have your graphs as accurate as possible, so kind of keep that in mind. Okay, let's take a walk on our graph. From left to right, we're going uphill. We hit that turning point, then we're going downhill. Okay, so that kind of cuts it in half as far as our intervals. So from left to right, we are increasing from negative infinity to 3. And again, this is the other way to write that. We hit that turning point, which is 3, 2. That's your turning point. That's your extrema. And then we go downhill from left to right. And it's always the x value. Think of your domain for your increasing, decreasing intervals. Okay? Now, do you think that turning point is a max or a min? Is it at the top of the mountain or is it at the bottom? It's at the top, so it's a max value. Okay? The end behavior. So again, here's your end behavior. Look at your arrows. As we go to the left, we're going to the left and down. So x approaches negative infinity when y approaches negative infinity. That's your left-hand end behavior. Your right-hand end behavior, x is going to the right, so x approaches positive infinity. Y is going down, so that approaches negative infinity. So there's a typical absolute value function. All right, next up is our cubic function. This one goes left 1, up 1. Okay, left 1, up 1. So get your 2 key points there. Now from there, from the key point, if we go right 2, we go up 8. From the key point, if we go left 2, we go down 8. So they're kind of off our screen. So that's what your equation, or the graph should look like. So x-intercept, -2, 0. That's your 0 of the function. The y-intercept, 0, 2. Okay? Now, from left to right here, we are going uphill the whole way. So we are increasing from negative infinity to positive infinity, which means there is no turning point. Okay, no turning point here. And behavior, again, look at your arrows. As we're going to the left, where are we going? Well, x is going to the left, y is going down, so x approaches negative infinity, y approaches negative infinity. As we're going to the right, here's right-hand end behavior, x approaches positive infinity, y approaches positive infinity. So there's a typical cubic function. All right, next up, square root function. So this graph goes to the left 1, down 2. So if we build that graph, we go right 1, up 1, from the key point, right 4, up 2. So that is how you would graph that particular function. So x-intercept, 3, 0. Y-intercept, 0, -1. So make sure your graphs are as accurate as possible to get those 2 points. Sometimes there's multiple points for the x-intercept. Okay, now here it gets a little tricky. When we take a walk on this graph from left to right, we're definitely going uphill. But where are we going uphill? We are increasing from -1 to infinity, okay? From -1 to infinity. That is where we are increasing. We never hit a turning point here. Okay, so in this particular graph, we're always going uphill from left to right. But look at that interval, -1 to infinity. Now, end behavior. As we go to the left on this guy, we stop at this point. So our left-hand end behavior, x approaches that point, -1, and y approaches -2. That's your left-hand end behavior. Where is our graph going? Our right-hand end behavior keeps going. So x approaches positive infinity, y approaches positive infinity. So there's a typical square root function. All right, next up, cube root. So this graph goes right 1, down 1. Okay, get your 2 key points. Now remember, this is cube root, so it goes more left to right. So from that key point, if I go right 8, I would go up 2. From that key point, left 8, down 2. Those are going to be off our graph here, so we get this. Okay? The x-intercept, 2, 0. That is your 0 of the function. The y-intercept, 0, -2. Where does it touch the y-axis? Okay, let's take a walk from left to right. We are going uphill the whole way. So we are increasing from negative infinity to positive infinity. No turning point, okay? Well, you're not always going to have a turning point, as you can see. You definitely have turning points for the quadratic and absolute value. All right, and behavior, as you go to the left, x approaches negative infinity, y approaches negative infinity, as you're going to the left. As we go to the right, x approaches positive infinity, and y approaches positive infinity. So you always have a left-hand end behavior and a right-hand end behavior. And it's customary to put the left-hand end behavior first. So that's a typical cube root. All right, so now we get to the fun ones. The rational function, if we look at this one, hopefully you can tell that this one goes to the left 2. Okay. It doesn't go up or down. So there's your asymptotes. We've already talked about this. So your vertical asymptote, x equals -2. Your horizontal asymptote, y equals 0. Okay? So we get our 2 key points, and we draw our graph. Okay? Now, this particular one does not touch the x-axis. So that means there is no x-intercept. The y-intercept gets a little tricky, but if you replace the x with 0 in the equation, you're going to get 1/2 for the y value. So there's your y-intercept. That's where it touches the y-axis. Okay, now as far as the other stuff, it gets quite tricky. We do not have a turning point. Okay, we do not have a turning point. With the end behavior, we're not going to really focus on that. They will ask you a specific question, you know, what happens when x approaches -infinity? Okay, what is y approaching, and so on. So we're not going to really focus on end behavior with the rationals. Same thing with increasing, decreasing intervals. From left to right, we're actually going downhill, but we have a break in the action with that vertical asymptote. So we're not going to really, we'll talk more about this later, okay? We'll talk more about this later. So I'm just going to put question marks there. So that's a typical rational function. So now we have our exponential graph. This one goes up 2. Okay, this one goes up 2 because that will be your horizontal asymptote going up 2 with it. Okay, so the key point would be 1 above that, then right 1 up 1, right 1 up 2, and so on. So this one goes something like that. All right, so the x-intercept here, not happening. We do not touch the x-axis. The y-intercept is 0, 3. If we take a walk on this graph from left to right, we're going uphill. Okay, so we are increasing the whole way. Think of your domain. The domain would be, you know, x such that x is an element of all reals. So from -infinity to infinity, we're increasing. We never turn and go downhill, so there is no turning point on exponential graph. Our end behavior, as we go to the left, be careful here. X approaches -infinity. Y approaches 2. That's your horizontal asymptote. So as we keep going to the left, x is going to get smaller and smaller and smaller. Y is going to get closer and closer to that 2. Your right-hand end behavior, as we're going to the right, x approaches positive infinity. And y also approaches positive infinity. Okay? So that's your typical exponential function. And last but not least, the logarithmic function. This one goes left 4. Hopefully you can see that from that equation, left 4. That is your vertical asymptote, which we had talked about before. So x equals -4 is your vertical asymptote. Your key point's going to be right here, right 1 up 1, right up, be easier to say up 1 right 2, up 1 right 4, and so on. So that's how you build your logarithmic function. Okay, so on this particular one, our x-intercept is -3, 0. Our y-intercept, 0, 2. Okay, so from left to right, let's take a walk. We're going uphill, aren't we? From left to right. But where are we going uphill? We are increasing from -4 to infinity. So that's your interval. Again, think of your domain. Okay? We don't hit a turning point on this one. Your end behavior, as you're going to the left, be careful here. X is approaching -4. Y approaches -infinity. So as we keep going left, X is going to get closer and closer to -4. Y is going to get closer and closer to -infinity. As we go to the right, X approaches +infinity, and Y approaches +infinity. So that concludes Unit 1, Day 4, about all of our characteristics.